How time travel can be possible? Science says time travel is possible. Science does support some amount of time bending, though. For example, physicist Albert Einstein's theory of special relativity proposes that time is an illusion that moves relative to an observer. An observer traveling near the speed of light will experience time, with all its after effects, boredom, aging, etc., much more slowly than an observer at rest. That's why astronaut Scott Kelly aged ever so slightly less over the course of a year in orbit than his twin brother who stayed here on Earth. A famous scientist named Albert Einstein came up with an idea about how time works. He called it relativity. This theory says that time and space are linked together. Einstein also said our universe has a speed limit. Nothing can travel faster than the speed of light, 186,000 miles per second. Albert Einstein's theories of relativity, which set out a description of space, time, mass, and gravity. A key outcome of relativity is that the flow of time isn't constant. Time can speed up or slow down, depending on the circumstances. For example, time passes more slowly if you travel at speed, though you need to start approaching the speed of light for the effect to be significant. This gives rise to the twin paradox, in which one of two identical twins becomes an astronaut and whizzes around in space at close to the speed of light, while the other stays on Earth. The astronaut will age more slowly than their Earthbound twin. If you travel and come back, you are really younger than the twin brother. Similarly, time passes more slowly for you if you are in an intense gravitational field, such as a black hole. In our everyday lives, these relativistic effects are too tiny to be noticed. But they do affect the satellites that we use for Global Positioning System, GPS. The clocks above click faster than the clocks on Earth. Relativity means it is possible to travel into the future. We don't even need a time machine, exactly. We need to either travel at speeds close to the speed of light, or spend time in an intense gravitational field. In relativity, these two acts are essentially equivalent. Either way, you will experience a relatively short amount of subjective time, while decades or centuries pass in the rest of the universe. Time travel through wormholes and black holes is theoretically possible based on Einstein's general relativity, but there are significant challenges. Wormholes as time machines. A wormhole is a hypothetical tunnel-like bridge that connects two different points in spacetime. If stable wormholes exist, they could allow for time travel under certain conditions. If one mouth of a wormhole moves at near light speed and then returns, time dilation would cause a time difference between the two ends. This means stepping into one end could bring you to the past or future. Wormholes require a form of negative energy, exotic matter, to remain open and traversable. Current physics suggests this might exist, but is highly speculative. Using a wormhole for time travel could create paradoxes, like the grandfather paradox, where someone changes past events, leading to inconsistencies. Black holes and time travel. Black holes have intense gravitational fields that warp spacetime, potentially allowing for time travel. If you orbit close to a black hole without falling in, time moves slower for you than for distant observers. This is a one-way trip to the future. If one enters a black hole, physics as we know it breaks down. Some theories suggest wormhole-like connections inside, but any traveler would likely be crushed by extreme gravity. Some physicists theorize that rotating black holes might allow closed time-like curves, CTCs, loops in time that theoretically enable travel to the past. However, stability issues and paradoxes make this uncertain. Time travel to the future is scientifically possible, and astronauts on the ISS already experience tiny amounts of time dilation. But large-scale jumps into the future would require extreme speeds or gravity, both of which we can't yet harness. Traveling to the past is far more difficult than traveling to the future. However, some theories suggest that it might be possible under extreme conditions. Time travel remains theoretical, but scientifically possible under extreme conditions. Future advancements in quantum physics and spacetime engineering may unlock its secrets.